Okay, so let's continue. So the next test is the independent sample test. And we have two versions of this test, one that assumes equal variance and the other one that assumes unequal variance. And the question that you will have in a test or an assignment or practice, it will be very specific. So for example, the question here is the mean of the annual income for males is lower, equal, or higher than females. Okay, and I need to say about the assumptions. So you would say here, for example, this question assuming equal variances. Okay, so the way to perform the test, here we have two variables. We have the annual income and we have the gender, right? So you understand, okay, so this is this is a test with two variables and assuming that the variance is unequal. So the test that you will use is called the t-test, income high by females. So you're testing income per gender. And the answer that we get, or the output that we get here, again, it's dividing the sample between gender, the mean of income for the males group, the mean of income for the females group. And you can notice just from the data that this number is bigger, so the mean of males is higher than the mean of females, but you want to test it. So you want to perform a statistical test. And the test is saying that the difference in means, which is this number, is equal to 0. It's like very, very small, that is statistically not important. So you test this difference, whether the mean of income for males minus the mean of income for females is equal to 0. And you have three different alternative hypotheses. The middle one is the default one, right? So whether it's equal to 0 or unequal to 0. And this one, whether it's equal to 0 or greater than 0. In other words, the mean of income for males is higher than the mean of income for females. And then the left test, or the other one-sided test, is whether the difference is equal to 0 or less than 0, or in other words, the mean of income for females is higher than the mean of income for males. So in order to read the output, you would look at the probability. This one, it's very small. And when I say small, I compare it with the 5% or the 1% or the 10% significance levels. And if you multiply this times 100, then it's going to be like 0.26% is less than all the numbers I mentioned, right? It's less than 1%, it's less than 5, it's less than 10%. So in other words, you would say there is a very small probability that the null holds true. There is a very small probability that the difference in means is equal to 0. And if the probability is low, then I can say we reject the null hypothesis. And we accept the alternative hypothesis that the difference in means is not equal to 0. The same conclusion holds here. So again, this probability is less than the 1, than the 5, than the 10%. This is 0.13% is less than the 3 conventional levels. So you would say, again, there is a small probability that the null holds true. So we reject the null and accept the alternative that the difference is positive. In other words, the mean of income for males is higher than the mean of income for females. Okay? This one is saying there is a high probability that they are equal to 0. This test prefers that we accept the alternative rather than saying that females make more money. So I'm writing everything here. So you can get a question: is the means of the annual income of for males is lower? This one is the lower, equal, or higher, the three tests, okay, than females, assuming equal variances. And I'm writing for you the answer here. So the p-value of the default one, which is the middle one, is less than 5% significance level. We conclude that we reject the null hypothesis and the difference in means between males and females okay, between males and females is different from 0, or it's not equal to 0. Also, we reach the same conclusion for the right-hand side, the one-sided right-hand side test, because again, the p-value is very low, lower than all significance levels, 5, 10, 1%, and we reject the null hypothesis. So we reject the, oh, I wrote it already. So we reject the null, I'm writing it here. So reject the null and accept the alternative hypothesis, which is, this is the alternative that we accept, and conclude that the mean of income for males is higher than females. What if you have the same question, right? And like this, let me copy paste the question and change the assumption of the variance. Is the mean of the annual income for males is lower, equal, higher than females, assuming, I'm gonna change this, unequal variance, okay? So this is the other test. The only difference is you go here and you add the word unequal, okay? And when you run it, the same way that we interpret the results. Looking at the one in the middle, there is 0.27% probability that the null is true. This is a very low probability compared to the 3 significance levels. Hence, we reject the null and accept the alternative that the difference is equal to 0. We reach the same conclusion under the one-sided right-hand side test, saying that we have a very low probability that the difference equals to 0. So we reject the null and accept the alternative that the difference in means is positive, or in other words, the mean of males is higher or statistically significantly higher than the mean of income for females. Okay? The last thing is the z-test. Okay, so we'll start it this week and then we'll continue it next week. So what is the z-test? So the z-test tests whether the mean of the sample is equal to a known constant. So I would tell you certain number, right? And this certain number, I'm saying, for example, education is equal to 13.83. And I will assume that I have a known variance. So I'm giving you the variance and I'm telling you that the variance is equal to this number, or the standard deviation is equal to this number, and so on. So you're testing the variable education, whether education is equal to 13.83 years and with a standard deviation of 1.81, and this is the command is z-test. You get something like this. I'm testing whether the mean of education is 13.83. The alternative here is not equal. The alternative here is greater than 13.83. The alternative here is less than 13.83. And again, as you can see, all of them are actually failing to reject the null. High probability that the null is true, because actually, based on the actual data, it's 13.82, which is approximately 13.83. So there is no way that we will reject the null. So we fail to reject the null. Probabilities are so high, 49%, 98%, 51%, which are all greater than the 3 significance levels. So our conclusion would be that we fail to reject the null and we accept the alternative. We fail to reject the null that the mean of the variable education is equal to 13.83. Okay, so we have it here. The p-value for the two-sided test is this number. So we do have statistical evidence to fail to reject the null that the mean equals to 13.83 at the 5%. You can actually say at all conventional levels, because actually this number is bigger than all of them. We reach the same conclusion for the other two one-sided tests and under all conventional significance levels as well. Okay, so whether I'm talking about one-sided tests or whether I'm talking about the other two significance levels, then under any situation, we fail to reject the null that the mean is equal to 13.83. Okay, so this week we learned these commands, the t-test under a certain pre-selected value. We also learned the paired t-test, where I have two variables and I'm testing whether their averages are equal or there is no statistical significant difference in their means, in the difference of their means. Here I'm testing the independent sample assuming equal variances. When I add the word unequal, then I'm adding the assumption that I have unequal variance. And then we ended by the z-test with known variance, okay, or with known standard deviation. And in a question, you will be given the mean and you will be given the standard deviation. You just plug it in to this command. Okay, so I'm gonna stop here and I'll send you another video next week.